Okay, so today we're going to be reviewing for your test on inequalities, which is Unit 5. This really focuses on three main areas. And if you remember, or you can go back and look at our unit Google slide, you can see the three standards that we're going to be focused on: solving, translating, and graphing. So that's it. So solving, not only are you going to have to solve and write your answer in set notation, which is what we're used to writing our answer in, but you also are going to need to be able to write your answer in interval notation. You're going to have to be able to translate inequalities as well as graph them. Translate real-world problems and solve and graph and write in interval notation more complex multi-step inequalities. So let's start with this first one. Solve, write your answer in interval notation. All right, this is a two-step problem. I can see that because here's my variable. I don't have to do any kind of simplifying, but I do have to get rid of 2 and I have to get rid of 5. And I'm going to get rid of my adding or subtracting first. So I'm going to subtract 2 on both sides. I get negative 35 on this side, 5x on this side. Change colors here. Going to get rid of that 5. My final answer is going to be this, but I don't really like how it looks that way. I like to rewrite, so I'm going to pancake flip everything over. Notice my symbol will also flip, but it will still point to the negative 7. So it's pointing to the negative 7 here, it's pointing to the negative 7 here. So here's my answer, but this is not interval notation. Remember, this is set notation. If I need to, you might want to do a quick little sketch of a graph. I would have a closed dot, arrow to the right. So my interval notation, remember, where the graph starts, where the graph stops, and then depending on my symbols, infinity always gets a parenthesis. Negative 7 in this case is going to get a bracket because I have a closed dot or because there's an equal sign in my set notation. And that is it. That is my solution in interval notation. Second equation, second inequality, again, I'm just going to solve. I can see it's a two-step inequality. I don't have anything to combine on either side. There's no split variable, there's no distributing, there's no combining like terms. So I have to get rid of my 5, and then I have to get rid of my negative 3. And change colors. Let's go orange. Right here, I'm going to give myself a star to remind myself, hey, I just multiplied and divided by a negative number. So my inequality symbol will change. It will flip around. And here is my answer in correct set notation. So again, you should know the difference between set notation and interval notation. And then the final question on this page that we're doing together right now, and we'll do the rest of it in a second, is translating. 15 less than 3 times a number is at most 29. All right, so I have less than, which sometimes means less than symbol and sometimes means subtract. But if it doesn't have is less than, remember when we looked at that first page of translating, it was always is less than, is more than. That means our inequality symbols. So in this case, because it does not say is, it means subtraction. 3 times, okay, we know what 3 times means. Is at most. All right, that's going to be our clue word for our symbol. So 15 less than. Less than, remember, we changed the order for less than. I want 15 less than something. It means I want something first. 3 times a number, and then I want 15 less than that. At most 29. All right, let's figure out that symbol. At most. That means the most it could be is 29, right? That's what at most means. So it could equal 29, right? But is it more or less than? If the most it could be is 29, it would have to be less than. So 3x minus 15 is less than or equal to 29. Copy this down, and we're moving on to the graphing and the translating questions below. Okay, number 4 says to graph the following on the number line. So we've done lots of practice with this. Let's see. 7 is going to go in the middle because that's the key number that's in this inequality. We're going to do 8 and 9 on this side, 6 and 5 on this side. I have to choose my symbol. Is it going to be an open dot or a closed dot? This time it's going to be a closed dot because I have an equal sign. And then less than, again, as long as my variable is written in that first spot, I can look to that arrow to help me. Less than means the numbers are this way. 5 and 6 are less than 7. So there you go. Again, when I'm looking at graphing and I'm looking at your graph, I'm looking to, did you number correctly? Did you use the correct dot? Did you draw your arrow in the correct direction? So those are the 3 things I'm looking for. Did you label it correctly? Did you select the correct dot? Did you draw your arrow in the correct direction? All right, I see a word problem. I'm going to get my highlighter out. Translate. An online electronics store must sell, ooh, here we go, at least, that's a clue word right there, $2,500 worth of printers and computers, it should say computers, each day. Each printer costs $50, and today they sold $1,350 worth of computers. If the number of printers is represented by the letter P, oh, I have to use P for printers. Write an inequality to represent this situation. All right. So let's start with the letter P. Now that I know P stands for printers, I go back in the problem and I figure out where were we talking about printers, right here. Each printer costs $50. So I know when we're talking about each printer, and the cost will go up and up the more printers I have. That's going to be multiplying. And it looks like they sold printers and computers. So here are my printers, and they sold computers. So it looks like we're going to add those 2 up. And I know that it has to go to at least 2,500. So again, I always think of a situation in real life. At least is a really common phrase for real world inequality problems. So for example, you have to be at least 16 to drive. At least means you can equal it, but you also have to be greater than it. You can't be 15 and driving, at least not in New York. And that's it. I do not want you to solve it, just translate. So leave it the way it is, and let's move on to another type of problem. All right, so our next types of questions are going to be our multi-step inequalities. You have to solve, you have to graph, and if you even want to practice writing in interval notation also. I'm going to show you all the different parts of the answers. So this is the first one. Again, take a good look at it, start making a plan. What don't you like about it? We always like to focus on that kind of question because that usually leads us to our first step. What I don't like that there's x's on this side and x's on this side. So let's fix that. Again, I can move the x's. I can either move the 20 to the right side or the 11 to the left side. But remember, we typically like our variable on the left side so I don't have to rewrite it. So I'm going to do that. I'm going to move this 11x to the left side. And now it doesn't look so bad. Don't lose that negative sign, goes with this negative 116. And negative 20 minus 11x is negative 31x. And now I have what looks like a pretty decent 2-step equation. I have my variable all together. There's just one of them. I have to get rid of the 8 and the 31. Got to get rid of 8 by subtracting. And then I have to get rid of the 31 by dividing. And in this case, I have to divide by negative 31 on both sides. That should trigger something in your head. Oh yeah, I got to do something with that sign. I have to flip it. Final answer works out pretty nicely. X is greater than or equal to 4. Remember, this is called set notation. I can graph it from here. That symbol's telling me it's going to be a closed dot. My arrow is going to point to the right because these are the numbers greater than 4. And if I want to do interval notation, I could help myself by looking at the graph. Graph starts at 4 and moves until it gets to positive infinity. Infinity will always use a parenthesis because it never reaches infinity, but 4 will get a bracket because of that closed dot. That is part of my solution. And there's question 6. All right, moving on to question 7. Pause if you need to copy any of this down. All right, question 7. Taking notice of this inequality, I'm noticing that I have 2 variables on the same side. And I always like to clean up the sides individually first. So let's do that. I'm going to do that by combining the like terms together. Notice I'm not using inverse operations because they're on the same side. I'm just going to simply take them and put them together. Combine them. -5 and a +2 makes -3. And then I'm going to keep that 4 over here. Now I have a 2-step inequality. My variable's all by itself, minus these, except for these 2 numbers right here. Get rid of the adding or subtracting first. And then get rid of the multiplying and dividing second. Here we go, another one. Again, I do a lot of these tricks just to remind myself, because sometimes I get so, moved around with everything that I just kind of forget to do certain things. All right. Because I divided by a negative, my inequality symbol switched, but this is not going to help me graph, so I'm going to pancake flip it completely around. Everything flips around. The variable goes in the front, the number goes in the back, the symbol flips around. And so this is going to be, again, my set notation. Remember, when we are doing a number line with negative numbers, it goes backwards. So the smaller negative numbers are actually larger, right? -5 is actually a bigger number than -7. And we know larger numbers always go to the right. Because this is a greater than sign, it's going to be an open circle, arrow to the right. And then again, interval notation. The graph starts at -7, again moves to positive infinity. Positive infinity because, remember, as we continue on this number line, the numbers will get positive. Infinity always gets a parenthesis. Because -7 is not included, it will also get a parenthesis. And that is my completed interval notation for this solution. One last question and then we're done. Let's go. All right, and our last type of multi-step inequalities, distributing. I noticed some parentheses here, so I got to get rid of those before I can move on with anything else. So I'm going to distribute this -4 here. -4 times 5. -4 times -2x actually becomes positive 8x. How about that? Try that again. There we go. Okay, so we just distributed. Now I'm going to get rid of adding and subtracting, multiplying and dividing, and I'm done. Again, most of these follow a very similar pattern, and the more practice you have with them, the better they will be for you. Getting rid of the multiplying by dividing. I didn't divide by a negative, so my symbol stays the same. Answer is x is greater than 9. 9's going to go in that middle spot. It's going to have an open dot because it's greater than but not equal to it. These numbers over here are greater. And my final interval notation, graph starts at 9, ends at positive infinity. 9 gets a parenthesis because of that open dot. Notice it's almost like half an open dot right here. And then infinity always gets a parenthesis as well. That is my final interval notation. Again, knowing the difference between set notation and interval notation is going to be important for your tests. Set notation is our typical answer. Interval notation is what our graph looks like, where it starts and where it stops, or really like comes close to, because infinity, remember, never stops. All right, looking forward to seeing how you do on this test. Good luck.